Hi, welcome. My name is Richard. Today our discussion on vectors will be on finding parametric and symmetric equation of a line. I have a video where we find vector equation of a line when the Cartesian equation of the line is given, as well as finding a vector equation when 2 points are given. Today, before the video ends, we'll learn how to find the parametric and symmetric equation of a line when the Cartesian equation of the line is given. Then we'll learn how to find the parametric and symmetric equation of a line when 2 points are given. This will be a very interesting engagement, so please come along with me. Okay, so before we can find the parametric and the symmetric equation of a line, we might have known the vector equation of the line. Very, very important. So remember, to find the parametric and the symmetric equation, you need the vector equation of the line. So let's say a given vector equation of a line is this: r of t is equal to x1i plus y1j plus z1k, then plus t x2i plus y2j plus z2k. Let's say this is a vector equation of a particular line, where remember the x2i plus y2j plus z2k is a directional vector, if you really watch my video on that. So now we want to let r of t should be equal to x naught I plus y naught j plus z naught k. So in place of r of t, we substitute this. So what I will have? We'll have x naught I plus y naught j plus z naught k, and to be equal to x1 I plus y1 j plus z1 k, then plus t into bracket z2 I plus y2 j plus z2 k. Now let's expand this. That's, we distribute the t over this. So what are we having? We have x naught I plus y naught j plus z naught k will be equal to x1 I plus y1 j plus z1 k plus, now have x2 ti plus y2 tj plus z2 tk. Now group like this. I'll bring those with the i's together. So I'll have x naught I plus y naught j plus z naught k is equal to x1 I plus x2 ti plus y1 j plus y2 tj, then plus z1k, then plus z2 tk. So I is common to them. Let's factor it out. So what I will have x naught I plus y naught j plus z naught k, it will be equal to x1 plus x2t all times I. That means I factor the I out. Then plus y1 plus y2t multiplied by j, the same way z1 plus z2t multiplied by k. So when we compare this side of the equation to this side, we can say that, see, x naught is equal to x1 plus x2t, since they are both having a variable of I, or they are both in the I direction. So we can say that our x naught is equal to x1 plus x2t. Also, y0 is equal to y1 plus y2t, and z0 is equal to z1 plus z2t. Then we say this becomes the parametric equation of the line. This becomes the parametric equation of the line. I hope you get that. I hope you do. Now we learn how to find the symmetric equation. Then we take some sample questions and solve. So as I was saying, before you can find the parametric equation of a line, you need a vector equation. So it's out of the vector equation that will develop the parametric equation. Also, before you can find the symmetric equation of a line, you need the parametric equation of the line. So now, from our vector equation, we're able to bring out this parametric equation. Now let's find how we can find the symmetric equation from the parametric equation. So now, from our first equation, x naught equal to x1 plus x2t. We want to make t the subject. So what will we have? We'll have x naught minus x1 equal to x2t. When I divide both sides by x2, I'll get t equal to x naught minus x1 over x2. I hope you get that. Also, if we have y naught equal to y1 plus y2t, and we make t the subject, we have y naught minus y1 equal to y2t. And we divide both sides by y2, we have t is equal to y naught minus y1 all over y2. Also, the z2, we have z0 equal to z1 plus z2t. We want to make t the subject. We have z0 minus z1 equal to z2t. When we make t the subject, there our t will be equal to z0 minus z1 all over z2. So you can see that t is equal to the t is equal to that t. So we can say this equation is actually equal to this equation, also equal to that equation. That's x0 minus x1 all over x2 equal to y0 minus y1 all over y2, also equal to z0 minus z1 all over z2. Then we say this becomes the symmetric equation of the line. So this becomes the symmetric equation of the line. I hope you get that. So one thing you must know is that you need a vector equation before you can get the parametric equation. Also, you need a parametric equation before you can find the symmetric equation. Get this very well. So we take some sample questions and we learn how to find the vector equation, the symmetric equation, the parametric equation when the Cartesian equation of the line is given. So come along. Okay, so let's solve our first question. They say, find the vector, parametric, and symmetric equation of the line 3y equal to 2s plus 12. So remember, before we can find parametric equation, we need the vector equation. And before we can find the symmetric equation, we need a parametric equation. So now let's find the vector equation first. So we say that we must write this line to be in the form y equal to mx plus c, if you remember very well. So when we do that, 3y equal to 2x plus 12, y will be equal to 2x over 3 plus then 12 divided by 3 will be 4. where 2 over 3 is the gradient and 4 is the intercept of the y-axis, if you remember very well. So we can say our gradient m, which is equal to the change in y over the change in x, will be equal to 2 out of 3. Then the vector or the directional vector of our m will be, which is equal to x. You know, vectors, we write x before y. So this will be, the directional vector will be equal to, this is x and that's y. So we have 3, 2. Also, intercept of the y-axis, remember s is 0. So the intercept point, let's say P, will be 0, 4. Since the 4 is the intercept of the y-axis. Now the vector equation of this line is just giving us r of t equal to the point P plus t times the directional vector, if you remember very well. So you can say r of t is equal to 0, 4, then plus t times the directional vector, which is 3, 2. So we can rewrite this as in a scalar vector form as, since there's 0, we can say 0i, which is the same as 0. So we say 4j plus 3 plus t into bracket 3i plus 2j. So this or that becomes the vector equation of this line. I hope you get that. So since we know the vector equation, we can find the parametric equation. So we know the vector equation of the line to be this. Now we can find the parametric equation from it. So we say we let r of t to be equal to xi plus yj. So we can say xi plus yj will equal to 4j plus, we expand this, so okay, plus t into bracket 3i plus 2j. So what do we have? We can expand this. So we have xi plus yj equal to 4j plus 3it plus 2jt. Or let me bring the t first. Ti plus tj. So when we group like terms at this side, we have xi plus yj will be equal to 3ti plus 4j plus 2tj. Now we can factor out xi plus yj will be equal to 3ti plus 4 plus 2t bracket j. So we compare those carrying the I, and we can equate it. So we say x will be equal to 3t and y will be equal to 4 plus 2t. Then we say this is the parametric equation of the line. I hope you get that. So now that we know the parametric equation, we can also find the symmetric equation of the line. So since we know that our parametric equation as x equal to 3t and y equal to 4 plus 2t, we just make t the subject in each of the equations. So we say when we divide both sides by 3, t will be equal to x over 3. Then we have y minus 4 will be equal to 2t. We divide both sides by 2. Our t will be equal to y minus 4 all over 2. Then we can say that x over 3, since this is t and that is t, we can equate. X over 3 is equal to y minus 4 all over 2. Then this becomes the symmetric equation of the line. I hope you get that. I hope you get that. Now we look at a situation where 2 points are given to us for us to find the parametric and the symmetric equation. So let's solve our second question. Our second question is a line passes through the points A 2, 5 and B negative 3, 6. Find for the line its 1 vector equation, 2 parametric equation, and 3 symmetric equation. So remember, please check out my videos on finding the vector equation of a line when 2 points are given on YouTube. So we said that before we can find a parametric equation, we need a vector equation. So the vector equation of this line, r of t, is equal to the point A plus t times the directional vector of AB. We can use B2 if you remember very well. So we need to find the directional vector AB. The directional vector AB will be equal to OB minus OA. So what's our OB? Our OB is negative 3, 6, and our OA will be 2, 5. So our directional vector AB, so our directional vector AB minus 2 will be negative 5, and 6 minus 5 will be 1. So we can find our vector equation to be r of t. So this is our first equation, will be equal to the point, or the point A in a vector form. What is the point A? That's 2, 5. So we have 2, 5 plus t times the directional vector AB, which is negative 5, 1. You can rewrite this as as a scalar vector form as 2i plus 5j, then plus t into bracket negative 5i plus j. Then this or that become the vector equation of the line. Since we know the vector equation, we can find the parametric equation. So since we know the vector equation, we can find the parametric equation. So we know the vector equation of this line that passes through the point 2, 5 and negative 3, 6 to be this. So we can find the parametric equation. So we just let r of t, since there are two directional space, to be equal to xi plus yj. Then we can say our xi plus yj will equal to 2i plus 5j, then plus t into bracket negative 5i plus j. Now we can expand this. So we have xi plus yj equal to 2i plus 5j, then you can say negative 5ti plus tj. Now we can group like this. We bring the i's together. Have xi plus yj will be equal to 2i minus 5ti, then plus 5j plus tj. So what do we have? We can factor out our i's together. We can factor out our i's. We have xi plus yj will be equal to 2 minus 5ti, then plus 5 plus t or j. Now, since we're able to do that, you see that those carrying the i's can be equal to, since they are equal, both sides of the equation are equal. So we can say that our x is equal to 2 minus 5t, and our y will be equal to 5 plus t. Then this becomes the parametric equation of the line. So since we know the parametric equation, we can find the symmetric equation. Since we have found our parametric equation, we can find the symmetric by making t the subject in each of the equations. So I'll make t the subject. Here we have x minus 2 equal to negative 5t. We divide both sides by negative 5. We'll have t is equal to x minus 2 all over negative 5. You can rewrite this as the negative will affect them. So we'll have 2 minus x over 5. I hope you get that. Now we'll make t the subject to here. So this one t will just be equal to 1 y over y minus 5. Since we have t here and t here, we just equate. So we can say that our 2 minus x over 5 is equal to y minus 5. Then this becomes the symmetric equation of the line. I hope you understand that. Now we'll solve one more question on three-dimensional vector space. Then we take it from there. So before we solve our last question, please remember to subscribe to my YouTube channel if you are here to, and click on the notification bell. So the last question says, find the parametric and the symmetric equation of the line that passes through the points A 7, negative 3, 5 and B negative 2, 8, 1. So how do we do that? Please, before you can find parametric equation of a line, you need its vector equation. So very, very important. Let's find it. So the equation did not ask us to find vector equation, but we need it before we can find parametric equation. So the vector equation R of t can be equal to A, you can use B, is the same, plus t times the directional vector of A and B. We say that the directional vector of A and B will be equal to OB minus OA. So what do we have? We can have, what's our OB? Our OB is negative 2 is negative 2, 8, 1. So negative 2, 8, 1. Then minus A, which is 7, negative 3, 5. We'll simplify this further. What are we having? We'll have negative 2 minus 7, 8, then this will be 8 plus 3, then 1 minus 5. So our directional vector AB will be equal to negative 9, 11, then negative 4. So since we know our directional vector and we have our point A, we can find the vector equation. Then we can say the vector equation R of t is equal to A, which is 7, negative 3, 5, then plus t times the directional vector, which is negative 9, 11, 4. Negative 9, 11, negative 4, sorry. So we can rewrite our vector equation in the form R of t is equal to 7i minus 3j plus 5k, then plus t into bracket negative 9i plus 11j, then minus 4k. Then this or that becomes the vector equation. Since we have gotten our vector equation, we can find the parametric equation. So since we know that our vector equation, we can now find the parametric equation. So what do? We let R of t to be equal to, since it's three-dimensional space, we have xi plus yj plus zk. So now we let this to be equal to that. We substitute this in place of R of t. So we say xi plus yj plus zk will be equal to 7i minus 3j plus 5k, then plus t into bracket negative 9i plus 11j minus 4k. What do? We expand this. So we have our xi plus yj plus zk equal to 7i minus 3j plus 5k, then minus 9ti plus 11tj minus 4tk. So now we group like this by bringing the i's, the j's, and the k's together. Okay, so when we do that, we have our xi plus yj plus zk will be equal to 7i minus 9ti, then minus 3j plus 11tj, then plus 5k minus 4tk. So what do we have? We can factor out the i's, the j's, and the k's. So what we have xi plus yj plus zk will be equal to 7 minus 9t times I, then plus, I'll do it plus, so plus minus 3 plus 11t all times j, then plus 5 minus 4t all times k. So we have managed to factor out the scalars I, j, and k. So now you can see that on compare, our x will be equal to 7 minus 9t. The y will be equal to negative 3 plus 11t. And the z will be equal to 5 minus 4t. Then we say this becomes the parametric equation. So since we know our parametric equation, we can find the symmetric equation of the line. So since we know the parametric equation, we can find the symmetric equation by making t the subject in each of the equations. So we can say 9t is equal to 7 minus x. That's, I brought the 90 and send the x there. Then our t will be equal to 7 minus x over 9. Then this place too, I can say y minus 3, y plus 3 is equal to 11t. So our t will be equal to y plus 3 all over 11. Then this case too, we can say 4t is equal to 5 minus z. Then t will be equal to 5 minus z over 4. So there is t equal to them. Then we can equate all of them as 7 minus x over 9 is equal to y plus 3 over 11 equal to 5 minus z over 4. Then this becomes the symmetric equation of the line. I hope you get that. I hope you get that. Please, we'll end it here today. Remember to subscribe to the YouTube channel before you sign out. Until we meet again, my name is Richard.